We are solving AIPMT question on electric potential. Let me solve first simple problem. It says 4 point charges, their charges are given, placed at each corner of a square. The relation between small q and capital Q, which is for which the potential at the center of the square equal to 0. Let us try to draw what he is saying. He is saying there is a square. Let me draw a square. At 4 corners of the square, 4 charges, that what he has given for us, are placed. At the center of the square, one thing, whatever may be the distance, I need not calculate the distance. From each corner to the center, the distance is fixed. All are same. So this is the center. So we can write an equation for potential at the center, V at the center, as we have a formula. Potential is 1 by 4 pi epsilon naught Q by R due to this one minus Q by X due to this one minus small q by X due to this one plus 2Q by X due to this one 2Q by X. And at the center it is given that is equal to 0. So just equate to that 0. Then this 1 by 4 pi epsilon on the other side becomes 0. So if you take these terms, X is also common, that implies 1 by X of minus Q plus 2Q means plus Q, minus 2Q minus small q means plus Q equal to 0. So Q plus Q equal to 0, then Q equal to minus Q. That's how we get the answer, right? So it's a simple concept. Let's have a look at the other question also, the second part of the question. The second part of the question says 4 electric charges plus Q minus Q minus Q placed at the corners of a square as it is given here. You can see the electric potential at a point A, this is the point A, midway between the two charges. He has given that this is L and L, so this point will be automatically midpoint, right? Again the same concept, electric potential at point A is sum of electric potential due to all the charges. So due to this plus Q, 1 by 4 pi epsilon naught Q by L, because that is plus Q, this L is from here, it is L. Due to this plus Q also it is the same because the distance is same, plus 1 by 4 pi epsilon naught Q by L. Now due to this minus Q, what is the distance is? This is the distance. So this is L, this is 2L, this becomes root of L square plus 2L whole square is 4L square, that is root 5 times of L. This distance is also the same because this is also 2L, this is also L. So from here to the point A, the distance is root 5L. So for this minus Q, the potential is plus 1 by 4 pi epsilon naught minus Q, because that charge is minus Q in the problem. For the, due to the other one also the same, plus 1 by 4 pi epsilon naught minus Q by root 5L. This is all together is how much is the question, right? So 1 by 4 pi epsilon naught is common, Q is also common, in the denominator L is also common in all of the terms. So here 1, here 1, everything is taken out, here minus 1 by root 5, here also minus 1 by root 5. So this value is Q by 4 pi epsilon naught L 2 minus 2 by root 5. You can take this 2 also common. So what it will be? 1 by 4 pi epsilon naught 2Q by L 1 minus 1 by root 5. So look at the options. The second option is the right option. So while solving both these problems, we have used only one formula, one basic formula, one very basic formula. What is that? Electric potential at a point is 1 by 4 pi epsilon naught q by r is the formula we have used. And what thing that we have identified is potential is a scalar. Potential due to a positive charge is positive, potential due to a negative charge is negative. If you understand that basic aspects, you can simply substitute and solve the problem and get the answer like what we have got. That's it. Thank you for watching.